So this week we're going to work with ProcessModel. Yay! New software that you guys are going to learn how to work and how to do a bunch of fun stuff with. Yay! So you have to install it, right? So I told you guys in class, if you're a Mac user, it's going to be a problem. Yeah, but you guys are used to that. You always choose the hard road if you have a Mac, right? So you need to install Windows there with, Boot Camp or VirtualBox or something like that. It doesn't run in Macs. So be sure that before our class you get everything done and have ProcessModel working. I'm gonna start with some kind of concepts, but then I'm gonna jump into ProcessModel, and you have to have your ProcessModel so you can mimic what I'm doing and build the same thing as I'm building. So when we get to class, we can go to kind of more advanced models and analysis that were not done in the video. Okay, so process model, it's or process is it enables us to do some process simulation, right? And we learn about how to design a process, right? So to do the steps and to have swim lanes, so we need that. And we learn how to calculate capacity, right? But process model gives us a lot more stuff than only that. So it kind of adds to that tool set that you guys have. So first thing here is a video about some guidelines and ProcessModel. I suggest you watch it. I'm not going to record it again and put it back there like in a video. I'm just click there and watch the link. Okay, after this video, and here we have other tutorials that you guys can use to give some kind of cool things and kind of explain some of the things better. Okay, so the first question is, okay, what additional information the ProcessModel giving, right? So imagine that you have a process here that's happening in a Starbucks. You have a classical waiting line problem, right? So you have people that kind of decided to go to Starbucks. They're waiting in the line. We have the register and coffee making here, right? And for this example, let's say that arrival rate of customers is 2 per minute. Okay, so on average, 2 customers arrive every minute. Okay, so basically that means that 1 is arriving every 30 seconds. Okay, 1 is arriving at 30 seconds. And then here I have my process. So let's say you go there, you calculated this arrival rate, you went to the process, you calculate the process time. And basically the capacity of the process is 2.4 customers per minute, right? And the cycle time of 25 seconds. So if you do all the math in the capacity planning, and let's not think about rework and all that stuff, simple looking at these two numbers, do we have capacity for that demand? Can we cover the demand? You can go back here, right? 30 seconds, 25 seconds, so I'm faster than the arrival rate. So yeah, I can cover that demand. But the second question is, okay, but am I going to have a waiting line? And how many people usually are going to be there? What is the average time that people will take to go over my process? And those questions are kind of a little bit more difficult to understand if you don't understand the arrival rate. What does that mean? Well, that means that 2 on average per minute. But it's not basically saying that every 30 seconds 1 person will arrive. Well, you're going to have some variation. And usually this variation of arrival rate is explained by the Poisson distribution, which tells you the probability of a number of customers arriving at every 30 seconds. So I can have, or in this case, every minute. I can have 0 customers per minute. I can have 1. I can have 2. I can have 3. I can have 4, 5, 6. But I can have even 10. Right? If it's a bus stop there and 10 people go there at the same time, I have 10 customers arriving. Okay? So that's what this axis is showing. How many people are arriving, and that's the probability. So it is about 26% the chance of 1 person. It is about 14% chance of 0. But whenever it's more than, and about 26, 27% of 2, but whenever it's more than 2, what does that mean? Well, it means that you're going to create a waiting line, right? Because it's going to arrive 3 people, and I only can take 2.4 So it's going to increase 0.6 person in my waiting line. What if arrive 10 at the same time and I can only cope with 2.4? Well, that line will be a lot bigger, right? So because of this variation that's occurring every minute, the line can go bigger, right? And now we're only considered that average is 25 seconds. So it means that every coffee I'm going to take 25 seconds to produce. Every coffee, doesn't matter. If you do a just American coffee, or if you do a chocolate white mocha with soy milk and whipped cream and whatever else you can put it, vanilla and whatever, right? So it'll take more time. Or if I ask 10 coffees, right? It will take more time. So it's also have variation on the production side. So the average 25, but sometimes it's going to take 10 seconds. Sometimes it's going to take 40 seconds, right? Or a minute, depending on how, or more, right? So what does that mean? It means that every minute it's going to be a different variation of arrival rates. It could be from 0 to 10. It could be a different variation of cycle times that could be 10 seconds to, in this example, to 40 seconds. And everything is happening every minute. So although the capacity is okay, my waiting line can increase and decrease based on that variation. And that's what process model is all about. That's the cool thing about process model. Because before, we only had the core processing time, which we still have here, but we didn't have the actual time, right? Remember, the actual flow time? Now we can calculate the actual flow time if we put all those inputs into the model. If we put all the distributions in the model, we can say, oh, the actual flow time will be 10 minutes. And I'm only going to, the average coffee making time is 30 seconds. So the waiting time is going to be 9 minutes and 35 seconds. Right? So now I'm going to be able to calculate the actual time, actual flow time, without going there and calculating and collecting data about. And also, I can tweak some of those things and find out what is the impact of my improvements. Wow. Using a statistical distribution for every step of the process. So that's the key of process model. It's not static like a capacity calculation, where you have just one number. I can use distributions and variations to see the collective impact of those distributions, which is a lot more similar to reality, right? A model is always an oversimplification of reality, right? Whatever you're modeling, it's always going to be too simple, right, comparing to reality. But these kinds of models in process model gives you a little bit more close to, gets you a little bit more close to reality, because it covers that variation, okay? So here we have the example that we're going to do with process model. So in this one, we're going to have, again, exponential distribution, okay, or a Poisson distribution here. I know you guys know a lot about exponential distribution after 2020 happened. And we have the arrival rates, which will be an average 15 minutes. And we have here also a service rate, right? A process rate, okay? And let's say that average every 12 minutes. So one customer arriving every 15, and process one every 12. So good with capacity, but let's find out, use the software to find out how long it takes, and how do I use my resources there, and other kind of cool information about it, okay?